Hello, everybody. Welcome to this third episode of Studying for the GMAT in 2025. Links to the prior two episodes will be in the chat window. I encourage you to watch them. They are all pretty good. This time, our focus is on verbal and data insights. And spoiler alert, there's going to be a little bit of quantitative content as well. So that is what we are getting ourselves into today. We begin. The unifying theme of this presentation, in fact, is inference. Inference is everything on the test. When you're studying for verbal, inference is going to be a skill you have to explicitly learn for both reading comprehension and critical reasoning. But that skill is going to transfer across the entire test. Indeed, the entire test can be seen as largely an inference test. That's the skill we're focused on. Now, to echo some things from previous sessions on studying, don't study in large blocks. It's like going to the gym for 4 weeks at a time to just do legs, and then going to the gym for 4 weeks at a time, or whatever your torture institution of preferences. Going 4 weeks at a time and just doing your arms, and then going 4 weeks at a time and just doing your core. By the time you get to the end of the 12 weeks, the legs that you started with for the first 4 weeks, they're gone. It's like nothing's ever happened, right? So this isn't an effective way to study, even though it feels really, really natural. Instead, in the early phases, you want to mix it up in terms of what topics and what formats you study, right? So study schedule for a week could look like this. Try not to study every day. You need a day off, but in a week, studying 6 days, totally reasonable. Don't just do quant, then just do verbal, then just do data insights. The test is a cross skills test, and learning happens better when you mix things up. Now, one bit of study advice that didn't show up in the earlier episodes, and I want to put out there now, is this is really good for your early studying when you're just trying to get the content under your belt. But maybe some of you are past that. You've already got the content. You know what it is, but you're still having trouble improving. That puts you in late phase studying, right? And late phase studying needs to go a little bit differently from early phase studying. Because in late phase studying, you want to be doing a lot more test-like practice, right? Random timed sets, okay? Groups of 5, groups of 10, groups of 21 or 20 or 23 questions would not go amiss under timed conditions, right? Because as anybody who's taken a practice test kind of midway through their studying will tell you, time management's the hardest thing. Learning all that early stuff, that's fine. But time management, how do you beat that? Well, one thing is you've got to practice timed. But you cannot just do timed random practice, even at that stage, because then there's nothing that you can really build on. So instead, you've got to mix it up a little bit with some targeted practice. All right. Timed random practice for 2 days. This day continues that day. But follow it up with some target. So over those, say, 2 days of timed random quant sets, you're going to do some review. Every time you do timed practice, you have to do untimed review, or it is worth nearly nothing. Okay, you do your growth in the late stages of studying from reviewing questions. But that review also doesn't get you too much unless you go forward and try to use the stuff that you've been reviewing. And so it's important to intersperse random practice sets, timed practice sets, with some targeted sets that are responsive to what you're seeing in those random sets. The point of doing timed random sets and reviewing them is to get takeaways from those problems. You use those takeaways on other problems. That's the idea anyway. But if all you do is timed random practice, then you're just kind of waiting for an opportunity to spontaneously arise to use takeaways. And that opportunity may not arise anytime soon. And it may also be, and it often is also the case, that when that opportunity does arise, if it's arising in a timed random set, you'll miss it. Because a lot of times when we're in our timed random sets mode or our practice exams mode, we're not really thinking straight. We're not thinking about all the things we've ever learned. We're in go mode. We just want to get started on the problem, get to an answer quickly, because we know there are 10 other problems waiting that also need our time, right? So it's hard. It's hard to try to implement new skills in that kind of setting, right? You want to get there eventually. You want to, of course, be able to implement all your skills in a timed random setting. That is, of course, the real exam. But you need to help yourself get there. And that's what interspersing targeted practice in between random sets is so important for. you're going to that targeted practice not only to see some topics that you maybe struggled with in those sets, but very explicitly to use takeaways you got from reviewing those sets, right? So your late phase studying is random practice, review, trying to get takeaways from those problems, how to do them faster, how to do them in different ways, how to just overall do them better, even which ones to skip, how to make educated guesses better, and things like that. You're using the time sets and the review of the time sets to figure out what skills you want to hone. But then you need to give yourself some time to actually hone those skills. And that's where targeted practice comes in quant, in data insights as well, even in verbal, but to a lesser degree. Do more timed random sets after that. And then 1 day a week, when you're in your late phase studying, have an overall review day for the last 2 weeks, right? So on this day, you're targeting a couple of topics, right? There we go. You're targeting a couple of topics, but maybe you have like 5 topics you want to target, or maybe just those 2 topics aren't enough. Or maybe you had some topics the previous week that you're not really focused on this particular day. That's what your review day every week is about. You want to figure out what you went wrong in and try to, again, apply those lessons to other problems, all right? So having a unified review day, really important. Following that up then with a follow-up day in which you find more problems, not necessarily in the same topics or even necessarily of the same types, but more problems that test the same kinds of skills is what ends up really mattering, all right? And if you're not dedicating at least 1 day a week to review and follow up in your late stage studying, I would, as you see here, say 2 days a week would probably be ideal. You're going to find that you keep spinning your wheels. You keep studying and you keep like going to explanations and feeling like, I get that problem. I've learned something from that, but it's not translating to points. You need to integrate what you get from your review into your practice by doing some of that follow-up deliberately so that when you then in the next week get to more random timed practice, you have a much better chance of seeing an opportunity to use a takeaway and actually spontaneously using it because you've given your brain some time and space to integrate those takeaways into your general practice. Okay, so late stage studying can't be just targeted practice in a round because that's not the way the test is, but it also can't be just random timed practice because you still need to grow from that random timed practice. The random timed practice generates takeaways, but without follow-up, those takeaways just disappear, right? Just like all your gains at the municipal swimming pool, all right? And you should, of course, also follow up with practice exams at that point because practice exams are the ultimate random time sets, right? But every time you go into a practice exam in your late phase studying, you want to go in with a list of objectives. Like, okay, here are the things I feel like I've really taken away or really been working on these last 2 weeks. I want to make sure if I see this, I do this thing. If I see this, I do this thing. Again, just kind of know what your takeaways have been, know which ones you want to employ on that practice exam. Write them out on a piece of paper that you have next to you as you do the practice exam and really focus on using them whenever possible. Your studying in the late phases is meant to make your habits better, habits about how you read and interpret and react to and ultimately solve the problems on the test, right? It cannot just be random. All right, now that's the big study pitch. Let's talk more about this whole verbal and data insights thing. All right, so as I mentioned before, the big skill in verbal and data insights and on the test at large is inference. All right. The official guide has a really, really good take. I think at the beginning of chapter 8, whatever its verbal practice chapter is, the official guide has a really good take on what they consider inferences. They give some pretty good examples. They tell you what kind of question types are asking for them and things like that. So some of this stuff you may already have seen in the official guide, and you may be wondering, yeah, but what does that mean for me? That's what we're going to practice skills-wise right now. All right. So there are some very specific types of inference that come up time and time again, because we all probably know by now. If you don't, you're about to. What the test means by inference is not what you may have grown up thinking about as inference. It's not like conjecture. It's not speculation. It's not calling for any of that because it's a standardized test. The test makers have to be able to stand up and say, no, this answer is right. No doubt about it. Clear as day, this answer is right and these 4 answers are wrong because this one as to be true based on this stuff that's said over here, right? Like, especially in reading comprehension, the test is self-contained. Everything you need is in the passage, right? And so the right answer has to be based on stuff that is actually in the passage, not stuff that you have to necessarily connect to outside knowledge. In fact, outside knowledge is usually a bad thing, but stuff that's very much contained in the passage. And so the question becomes, how can they make difficult questions when the answers are right there in the passage, right? How can they make it difficult? It's the styles of inference they use, right? It's the skills that the inference requires. So we're going to outline all the inference skills, at least the 4 major inference skills that you're going to see time and time again. We're going to see how they play out in real problems. That's the plan right now. Of course, if anybody has questions along the way, pop them in the chat window and I will try to get to them either in line with what we're doing or at the end. Okay? For now, get ready. Inference style number 1 is synthesis. It is easily, I would say, the most common inference style that's tested across the exam, though it's not necessarily the most common inference style that shows up in the verbal section. Right? Synthesis is just putting things together, right? So, for instance, if you know that A equals B and you know that B does not equal C, right? Pretty clear inference there. A equals pineapples. No, A does not equal C. That's the basic nature of a large amount of the inference you're going to be doing on the test. It's connecting the dots. It's what happens in quant word problems, for instance. You know, they ask you, what is the price of eggs at the end? They've got to have mentioned something about the price of eggs elsewhere in the problem, and you have to take what they said about it there and connect it to what they're asking about down here. It's very much a connections game. Let's take a look at a short passage. I'm going to give you guys time to read the passage and try to answer the question. Again, the chat window is your friend as you're trying to answer this question. If you feel like putting it out there to impress all the future watchers of YouTube, put your answer out there. If not, it's okay. We'll take just a minute to read the passage and think about what you would answer here. Again, if you feel like you have an answer and you feel like the good people of future YouTube should know, put it in the comments, put it in the chat. Now, what makes this an inference question? This is probably, for those of you who've studied for the test and aren't totally new to it, this is probably what you think about when you think of inference questions, right? This is one of the more classic presentations of inference. It's a reading comprehension passage, and the question asks what the passage suggests, what the author suggests, what can be inferred from the passage, what the passage implies, or various other things. What the author would be most likely to agree with is another fairly common type of inference question, right? So you see the passage suggests, and if you've seen these questions a bit, you might be a little nervous. You're like, okay, so the answer is not going to quite be there, right? Like they're not going to come out and say it. I won't find the answer exactly replicated maybe in the passage, but nor will you have to speculate on anything, right? It's just about some version of connecting the dots or another type of inference, right? And so what you do is chase down the details. What is it said about the strong nuclear force? Unfortunately, the whole passage here is about the strong nuclear force, right? So they could go any number of ways, which means in this case, you might have to go answer choice by answer choice and take details from each answer and say, okay, what did the passage say about the strong nuclear force and say electrons it mentions in answer A, or the electrical repulsion between protons in answer B. And you'll find information on those things. Then you've got to check, okay, does the passage actually say what this answer is saying? Does it try to communicate this same idea in the passage? And your final check is usually, and is it too extreme in the answer choices? Is the answer choice more extreme, more definitive, more just strongly worded than what the passage can support? That tends to mean that in classic inference questions like this one, weaker answers, more wishy-washy answers go to the front of the line. They're just more likely to be true. And your only standard for correct answer on inference questions is this answer 100% true, right? 4 of the answers will not necessarily be true. They might be true in the real world. They might be somewhat hinted at by the passage, but they won't necessarily be true. Only 1 answer is necessarily true because it can be built out of the passage. All right, now, thought a lot just to see if anybody would put answers out there. Let's talk about it. So electrons are mentioned, looking at answer choice A. Electrons are mentioned at some point in the passage, right? They're mentioned like somewhere toward the middle, the like third of the way down. It says, in contrast to electrons, which circle nuclei, nucleons are made of smaller constituent stubbed quarks. Now that doesn't say anything about the strong nuclear force, but of course we know you're going to have to connect the dots sometimes. And the strong nuclear force is, or the strong force rather, is mentioned in the following sentence. It says, okay, the 3 quarks in each nucleon are bound together by the strong force, which operates only on quarks and on gluons. And it goes ahead and tells us what gluons are, just in case you were interested. I know I was. Now, is it fair to say from that the strong nuclear force does not influence the behavior of electrons directly? Quite possibly, right? So let's play the game. We know that the strong force operates only on quarks and gluons. All right, so operates on presumably means something like influences their behavior directly, right? It acts directly on quarks and gluons. But what do quarks and gluons have to do with electrons? Well, we see in the previous sentence that quarks make up nucleons, right? Quarks make up nucleons. And nucleons are in contrast to electrons, right? So nucleons are made up of smaller constituent stubbed quarks. That's in contrast to electrons, right? So when we know that the strong force operates on quarks, we know that it operates, therefore, on nucleons, which are themselves made up of quarks, right? That's a synthesis. That's connecting the dots, right? Strong force is connected to quarks. Quarks are connected to nucleons. But nucleons are not equal to electrons. They are in contrast to electrons, specifically in that nucleons are themselves made up of smaller constituent particles called quarks. So the contrast is electrons are not themselves made up of smaller constituent particles called quarks. Are they made up of gluons? No, gluons are defined as simply short-lived particles exclusively existing to carry the strong force between quarks. So is it fair to say that the strong force does not influence the behavior of electrons directly? Absolutely. Absolutely. And here we really have 2 kinds of inference in one, and I'm going to get to the second one in just a moment. But because the strong force operates only on those 2 things, and because electrons are presented as something different from nucleons, in that nucleons contain quarks, electrons by inference do not contain quarks, that's our second style of inference right there, it is absolutely fair to say that the strong nuclear force does not influence the behavior of electrons directly. Compare that now to the other answer choices. Can we say that the strong nuclear force is more powerful than the force of electrical repulsion between protons? The passage gets close to saying that, right? Toward the end. It says that leakage of the strong force from within each trio to nearby quarks within other nucleons permits 2 adjacent protons to fuse into one nucleus, right? But it also points out that those adjacent protons at greater distances would mutually repel because of their similar electric charge. And so it seems at certain distances, the strong force is more powerful than the force of electric repulsion between protons, but not at other distances. So can we say B is a blanket statement? No. B would be an example of something that's a bit too definitive, or at least is presenting one of two possible outcomes as though it is the outcome, right? That's the way that inference questions go wrong. And it feels pretty connected to the passage, notice. But it presents itself as too one-sided. It doesn't hedge enough, and that makes it problematic. Does it cause electrons to orbit atomic nuclei? No sense of that is really presented here, though that might be something else. Wink, wink, nudge, nudge. It's just not really found. And if information can't be found in the passage, then it's not the one. Does it fall off with increasing distance between quarks within a nucleon? Notice that D is meant to be kind of a bit of a distortion. It says it falls off with increasing distance between nucleons, and the electromagnetic force takes over, but it doesn't necessarily say much about increasing distance between quarks within a nucleon, necessarily. And does it account for the three-quark structure of nucleons? Maybe it does. They are bound together by the strong force. So in that sense, the three-quark structure depends on the strong force. But does the strong force account for the three-quark structure? The other interpretation, the kind of like flip side to E is, could the nucleon have more than a three-quark structure, and is it only the strong force that makes it specifically three quarks? And we don't necessarily know that. We don't know if it's because of some property of the strong force that nucleons only have three quarks. Could be that nucleons were always going to have three quarks, and the strong force just came along and said, you know what, I'll hold you guys together. Either way, we cannot say it for sure from the passage, right? A is the safest because we can build basically a bridge between what it says about the strong force to quarks, to nucleons, to not electrons, essentially. And that's the way inferences are built. That's how there's absolute certainty of the answer, even if the passage didn't explicitly say it. All right. Now, this brings us to our other kind of inference, and this is also a very major type of inference. Most of the inferences you see are going to be of these two types, and some, as we just saw in that passage, exhibit both at the same times. The second type is converse. All right. Converse usually involves reversing statements, especially if the statements are somewhat comparative, or reasoning by exclusion, right? Which is a bit of what we just saw to some degree, right? If the strong force acts only on quarks, that excludes its and gluons. That excludes the strong forces acting directly on anything that's not a quark or a gluon, right? That would be a converse, right? So you see a passage that says, okay, A is greater than B. The converse of that, the flip, is B is less than A, which doesn't feel like much of an inference. It never feels like you really get a satisfying thing out of that. But that is how a large number of inferences are carried on the test, right? You also see it show up in percentages a lot, and fractions a lot, and all sorts of quant or quant-adjacent problems. Everybody who's been studying a while will have seen some critical reasoning questions with percentages in them. If you haven't, you are in for a treat a little later. I don't want to give everything away, but stick around. If 65% of a population is X, you can infer by converse 35% of the population is not X, right? This kind of inference, you will recognize it, happens all the time in quant problems, happens all the time in data insights problems, happens a lot of the time in straight verbal problems, all right? They tell you one thing, and you're supposed to deduce the kind of shadow side of that, the flip side of that, right? That's a lot of what's going on in inference. Now, with that in mind, let's have a look at another type. This is a bit more of an exotic look at inference, and indeed the official guide that presents inference, the way the GMAT sees it, also kind of separates this type of inference out into its own little subcategory. All right. Again, I'm going to give you guys 2 minutes to look at this passage and try to answer the question. You don't need the entire passage necessarily, because you'll see the thing that the question's asking about is confined to just one paragraph, and also we're not going to see any other questions from this passage. So if you want to skip to the last paragraph and attempt this question, I forgive you. It's the right thing to do in this case. but still take a minute with it and see if you can come to an answer. All right. So the question asks what would qualify as an example of reverse redlining as defined in the passage. And again, reverse redlining only comes up in one paragraph. It's this last paragraph here. Redlining can lead to reverse redlining. And the paragraph goes on. Nice. Got our first answer out there. I appreciate you the most. Feel free to join your friend there in the chat if you believe D is the answer. If you think something else is, I'm going to save your YouTube reputation. Don't say it, because D is absolutely right. We get in this last paragraph a general description of redlining or reverse redlining, what reverse redlining is, right? Predatory businesses target minority or low-income consumers so they can charge more than would typically be charged for the same thing, right? And they go on to say when mainstream retailers don't service an area, these predatory businesses can move in, sell their inferior goods, sell them at higher prices, make out like bandits, and everybody loses except the predatory businesses. So what this question then asks for is, what's an example of that? And you'll notice, of course, from the answer choices get pretty specific, right? We're talking about people getting hired. We're talking about a bank refusing to offer mortgages, though that's, of course, kind of part and parcel with the rest of the passage. But then we got police in C, we've got a grocery store in D, we've got an auto insurance company in E, right? So we're getting some specifics here. Now, the passage didn't specifically talk about what the police were doing, at least in the part about reverse redlining, or what grocery stores were going to do, or what an auto insurance company was going to do, right? So this is the one type of inference that seems to call for a bit of speculation, right? We're definitely putting new stuff in the correct answer, stuff that wasn't in the passage. That is how this third type of inference rolls. Third type of inference is called application, in which usually the way it plays out when you're asked to do it is you're given some kind of general information in the passage, and then you're asked to choose a specific kind of demonstration of it, a specific example that accords with that general description. And indeed here, the answer is D. Now, why? Again, grocery stores weren't specifically mentioned in the passage, right? So it's not because of that, but then we start getting connections, right? A grocery store in a low-income neighborhood. Now, we are talking about predatory businesses going in to target low-income consumers, especially in certain areas where mainstream retailers refuse to go, right? So in a low-income neighborhood, that's presumably going to be a general place where there are low-income consumers, right? There's a connection there. That grocery store sells low-quality produce. Now, this thing did say that it would be an example of reverse redlining when these predatory businesses went in and sold inferior goods, right? Low-quality produce, absolutely a specific example of the more general inferior goods, right? And they're selling it for high prices, which very much reflects what's going on in the passage, knowing that most residents do not have the ability to buy elsewhere. Now, that's not specifically stated in the passage, though it is kind of implied, right? Like the people are in that area and they fall prey to whoever comes in. This like light implication is maybe it's because it's not that easy for them to go elsewhere. But at that point, this is kind of tacked on to the end of the answer, and it doesn't so much matter because even by the comma, we've already got a good example of reverse redlining. A business, a small retailer, a retailer of some kind has come in and is selling inferior goods at higher prices, right? Notice that that's not exactly reflected in any of the other answer choices. And so a lot of the other answer choices are just going to be like, no, you're talking about this, and the passage was talking about that. Seeing what police are doing to respond to crimes might well be an example of reverse redlining, but certainly not as it's outlined in that paragraph in the passage, because the police are not a predatory business per se. They're not retailers, right? They're not selling goods of any kind. And so C doesn't serve as a good example, just for instance, right? E, nothing about the insurance company, again, selling an inferior product to people who aren't serviced by anybody else or anything like that. That right there is how application goes. So application is, again, not as major as synthesis and converse. And it tends to honestly show up in wrong answers a lot more than right answers. A big part of what makes wrong inference answers wrong is those answers will try to overplay their hand a little bit on application, because application is two things. It's either going from general case to a specific case, as in the example we just saw. We got general truths about reverse redlining, and then the answer contained a specific case that went along with that general presentation. But application can also mean going from a specific case to a general case, as long as you qualify that general case. That is why you're going to see a lot of correct answers in inference questions have the word some in them, or may, or could. All of those are qualifiers. All of those lessen the force, the kind of assertive force of what an answer is saying, right? If I say that ice cream is the best, I've made a pretty big blanket statement. But if I say that some ice cream is the best, now you're interested. Now you need to know, which one does he think is the best? And it's absolutely cookie dough, all right? Some is a qualifier. Could, may, might, all qualifiers, and they all help an answer be true, especially in application settings, all right? So as an example here, and it's harder to do this one mathematically in a satisfying way, so we're turning to mice for this one. Thanks, mice. If you were to find out from a passage, like a critical reasoning inference question, we'll sometimes do things like this, that all mice are gray, or mice are always gray, or something along those lines. So that's a very general statement, right? What can you infer? Well, if you find out that there's a mouse called Dan, you can absolutely infer that that mouse is gray, right? That's going from general, all mice are gray, to a specific, Dan the mouse, he's gray. He's gray, right? If it's true for the bigger category, it's of course true for the specific thing. And that's, again, more or less what we just saw in that last question. But you can also make wider inferences as long as, we mentioned, qualify them, right? So if all mice are gray, then it's absolutely fair to infer some animals are gray, because just by dictionary definition, mice are animals. And you are expected to know that little bit of outside knowledge. And so it would be fair to have an answer that said some animals are gray. You couldn't say animals are gray, and you certainly couldn't say all animals are gray. When you're going from specific to general, you cannot go with the same strength. The qualifier becomes essential to creating a true statement. You can say some animals are gray, but nothing more extreme than that. You can also say some gray things are mice, right? Take the thing, flip it around, say it from the other point of view. All right, well, now we know that mice are gray, so we know there's some gray things wandering around that are definitely mice. Not all gray things are mice. That wouldn't be fair to say, right? Because gray is presumably a bigger category than just mice. But some gray things, absolutely. Right? Application is one of the trickier inference styles. Luckily, you'll rarely be asked to do it the way we just saw in the question. It does happen. I'm pretty sure it happened to me on my real test. It does happen, but it's not one of the more common types. Really, application is important so that you watch out for answer choices that overplay their hand. Try to overgeneralize or generalize in too definitive a way. It ends up ruining them. Application is also partly at play in a lot of inference questions. If we think back to the strong force and electrons question, they said electrons there, right? Because electrons are in contrast to nucleons, but they could have chosen anything that wasn't nucleons or wasn't made of quarks to put in that answer. They just happened to put electrons there because the contrast was really made right there between electrons and nucleons. It would have been fair to choose anything from the category of not made of quarks to say, yeah, the strong force doesn't actually affect those directly, right? My hair, the strong force doesn't act on the hair directly because my hair is not made of quarks. It's made of hair. I guess ultimately it's made of some quarks. I don't know. I've never asked it. All right. Application happens like that a lot. It goes with Converse a lot, right? If you say 65% of a population are X, then you can say also like a lot of things about that other 35%. You can say definitely that they're not X, but you can say 22%, at least 22% of people are not X, at least 5% of people are not X. And that would be an application too, right? They absolutely will do that in some answers. There's one in, I think, the executive assessment practice tests about minority businesses that uses this exact thing where the key number is kind of 17%. And the right answer says, oh, if at least 10% were to happen, it would be great. Well, that's true, but it feels pretty jarring because you're not seeing the exact number you want there. You're just seeing a thing that works technically because it's in the big group of numbers that could have worked to answer that question. All right, so application sneaks its way into the other inference questions that are going to be more predominantly type 1 or type 2 inferences. So it's best to know about it. And when you do see an application question, enjoy it, live in it, and try to extrapolate from there to other inference questions. See where it is showing up in those ones. Now, the last type of inference. The last type of inference is kind of an honorary type of inference, but it is hugely important to how you start to think about the test. All right, and so this is going to carry some weight. Again, you know the drill. I'm going to give you guys a minute to look at this totally new passage. You're learning so much today about science and reverse redlining. Give it a look. Think about what you'd answer. Again, feel free to put it in the chat window. Nice. Also, hey, Justin. Good to see you. All right. If anybody else wants to put an answer out there, you can. But if you argue with Justin, you're arguing with me. For twice the fun, I would assume. All right. Anybody else want to put anything out there? Going once, going twice. And gone. Nice. Nice. Right under the wire. All right, cool. Yeah. C is absolutely the answer, but let's break it down. Let's break down why. This question type is not what you'd like classically consider an inference question type. It's more of a purpose question, though it does have suggest at the end, so there's some inference embedded in it. But the overall structure of the question, the author mentions blank in order to, right? Or for the purposes of, or something along those lines. Very much a purpose question, right? And it's part of a wider category of purpose questions on the test, right? You, I'm sure, have seen primary purpose questions, right? Main purpose of the passage questions, purpose of the paragraph questions. There are these ones, but also boldface questions in critical reasoning, those ones with one or two boldface portions that ask, hey, what role is being played by these boldface portions here? That's a purpose question too, right? And purpose questions, especially specific purpose questions like this one, do require the same skills as inference, right? They require seeing connections between things. The thing that differentiates purpose questions from classic inference questions is purpose questions tend to ask why something is happening. And oftentimes the passage doesn't explicitly say, hey, this is why. Remember in the first one we saw, we had very clearly, in contrast to electrons, nucleons are made up of quarks, right? And so there was a clear kind of verbal connection there. You could follow the chain along very clearly. In purpose questions, there will still be words like that, words that kind of tell you where things are going, but you're essentially trying to read the author's mind a little bit. And the thing that kind of mediates these purpose questions is juxtaposition, right? It's the gluons of purpose questions. So you find where the detail is brought up. It's here toward the very beginning of the passage, right? Astronomers, it says in the first paragraph, nice job, you guys, that astronomers observed polar ice caps on Mars. But as to why it's saying that, like why the author mentions it, what the author is trying to suggest, we need to look around it, right? This sentence starts as early as the mid-17th century, which feels like, even from the beginning of the sentence, we're just being taken on a random trip to the past. But we got to look at the sentence that came before it too, because that's going to inform why we're taking this trip to the past, right? Sentence 2 didn't come out of nowhere. It has to be one of the kind of like the underlying fabrics of the test is it has to be connected to the prior sentence. Otherwise, it wouldn't be here. It's not just a series of haphazard sentences, a series of just random thoughts written together as though they're a paragraph. Every sentence that's there in some way responds to the sentence that came before it, in some way leads into the sentence that comes after it, except the first one, because there was no sentence before that one. Looking at that first one, though, it says, because of the proximity and likeness of Mars to Earth, scientists have long speculated about the possibility of life on Mars. Well done, scientists. And then we go, as early as the mid-17th century, astronomers observed polar ice caps on Mars. Now, what connects this second sentence to the first sentence unless you just assume that they have to be connected? There is stuff, but that assumption is still really, really important and powerful. Like, definitely assume it's connected. The stuff that like explicitly connects this sentence to the previous one, astronomers, Mars, right? We're talking about Mars here, and we're talking about scientists here. And hey, there's an application. Scientists is a general term. Astronomers are specific kinds of scientists, but that connection is absolutely there, right? So inference, the kinds of inference we're talking about, are actually just kind of required for how you're supposed to read these passages in general. Even if you're never asked a question about these first two sentences, reading them in this way, saying, oh yeah, this second sentence is picking up on that scientist thing that they just mentioned there. Seeing that connective tissue helps you to answer any kind of question that comes, especially inference and purpose questions, which is a lot. Now, looking at that first sentence, it says that scientists have speculated about the possibility of life on Mars because of the proximity and likeness of Mars to Earth, right? And so when we get to the second sentence and it says astronomers, these specific scientists, observed polar ice caps on Mars. By the mid-19th century, scientists discovered other similarities to Earth. You can see in that full sentence how much that sentence is reflecting the first sentence. They were talking about proximity and likeness of Mars to Earth. Scientists are trying to figure out if there's life. And we get the second sentence in which some scientists note that there are polar ice caps. And then some other scientists discover other similarities to Earth. Now, that word other is doing a lot of work, right? Because other similarities there implies that the polar ice caps that were observed on Mars count as a similarity to Earth. So even if you had no knowledge before this very moment that the Earth had polar ice caps, the words imply it necessarily, all right? That's, again, how these kinds of purpose questions roll. There are connections there. There are inferences to be made there. Understanding that those are always going to be there and that seeking them out will help you answer the questions. That's what the nature of this presentation on verbal and data insights is. Now, of course, we've confined ourselves to verbal quite a lot. We're going to get to data insights in a second. However, one thing, the answer is absolutely C, right? What are we trying to highlight here? Clearly from the end of that second sentence, similarities to Earth. Other similarities, including, of course, the similarity in the polar ice caps. How do we know we're doing that? The first sentence also makes it clear. Mars and Earth are close to each other and they are like each other. And the second sentence is talking about those similarities, that likeness yet again. And so you can infer that the author's purpose in bringing up this second sentence was to further discuss the things the author brought up in the first sentence. It is an inference, even though, again, these questions are often just phrased as the author mentions this in order to, right? As purpose questions. Purpose is inference. Oh, great question in the chat window, right? And very, very relevant to this particular problem. If the question says it's about the first paragraph, would it be wise to read just the first paragraph and arrive at the answer? Usually it's okay if the question explicitly says in the first paragraph. However, when a question just cites a detail that happens to maybe be in the first paragraph, you might need something from the second paragraph, or more commonly the reverse. Like if the question doesn't say in the second paragraph, blah, 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 but it cites a detail that's only in the second paragraph, there's a good chance you still can't answer that question without knowledge of the first paragraph. And so in general, I would say it's better to have knowledge of the whole passage, but in these kind of pretty rare cases in which they like specifically cite first paragraph, yeah. And there is a general truth to the fact that a lot of your inferences will come from stuff that's near. You know, if they highlight a phrase or something, the inference content will usually be in the surrounding sentences. But there are definitely times when they highlight something in paragraph 3, but the key to understanding it is in paragraph 1. As I've found out to my great embarrassment at times when I've gotten those questions wrong. So safe money is always on knowing the whole passage. But usually if they call your attention to some specific thing, the answer is going to be around there. That's just a rule of thumb. It's a usually. All right. Okay. Notice that B, for instance, as an answer, tries to overplay its hand again, right? They're making it clear that the fact that Mars had polar ice caps makes it similar to Earth, right? And on Earth, the polar ice caps are made up of water ice, allegedly. But that doesn't necessarily mean that that similarity extends to Mars, because the only similarity that sentence is really trying to point out is just that Mars had ice caps, right? We don't know much about their composition, and we shouldn't infer that level of similarity if that level of similarity hasn't been presented, right? So watch out for answers that overplay the hand. Those are, of course, the bane of your inference times. Now, let's extend it a little bit. So, seen a lot of critical reasoning, of reading comprehension style inference, and got this thing here for our fourth type of inference. Basically, just understand why information is there. That last one, though, is hugely a part of the fabric of the test. That's something that carries over to the other sections in a big way, as does number 2 inference, as does number 1 inference. Application is just there as a spoiler, but it is there. So, for instance, let's say that we were to look at this data insights question. Pretty clearly, for those in the know, a 2-part analysis question, and with a little bit more observation, pretty clearly a logic type 2-part analysis question, more on the non-math related side, right? There's not a lot of numbers here. There are some numbers, and there is indeed some math required, but just by and large, you would consider this a non-math related question, right? It's giving you a lot of text up there. It's giving you a lot of rules to follow, a lot of constraints to employ. It's giving you 2 partial lists of what's going on in these people's lives. And it seems to be a good time is had by all, right? And then it asks you what else can be included, right? But how do these questions really operate? They give you these rules up here, right? For instance, Bharat loves shopping for local crafts, so requested shopping activities on both days. And what you've got to do is take that rule, right? Shopping activities on both days, connect it then to what we know about both days. Is there a shopping activity on day 1? And indeed there is, Las Ramblas. Cool. Is there a shopping activity on day 2? Yeah. Yeah, Barri Gótico. So, just happy. Love shopping for local crafts. He's satisfied. And from there, you can just say, you know what? You're good. We don't need to worry about you anymore, man. We got you taken care of. You go to the other rules. And again, try to synthesize those other rules with what you know about there, and also use converses. So Converse, for instance, it tells you at the end of that blurb up there that the friends have 12 hours each day to devote to activities. And they've decided on, of course, these partial lists. Converse side of that, pretty clear and pretty necessary to doing this one. Take the hours that they've already got scheduled, right? 3 hours for Parguel, 1 hour for Catalunya Miniatura, 4 hours there, 3 hours there. That is a cool 11 hours, right? So by exclusion, we can reason that the only kind of activity that can go on day one is a 1 hour activity, right? And that in turn allows us to exclude a bunch of activities from possibilities for day one. Sorry, Pueblo Español. Sorry, Museo Picasso. Sorry, Marbella. Just gone, like that. That's inference right there, right? That is reasoning by exclusion, taking something that's there, combining it with stuff that's there already, that's synthesis, and then saying, okay, I got 11 hours there. They said 12 hours. The gap between them, the part that's not addressed, is a 1 hour gap. And then boom, take it to the answer choices, and application is what happens then. You take now this synthesized and converse rule that you've got 1 hour left, you apply it to the answer choices, it gets rid of at least 3 of them for that particular column. That is inference in action in data insights, but it's not just there. Even in more mathematically inclined data insights questions like this data sufficiency question, this is a very mathy question, right? Like less than 0, greater than whatever, not equal to 0. It's mathy, we would have to admit, right? But is inference important? Absolutely. Now, the thing that's different with mathematical inferences, right, or more mathematical inferences, because it's all still logic, is you're synthesizing what you're told with stuff you just generally know, stuff you've studied to be ready for the quantitative section, right, or for the data insight section's quantitative questions, right? So you might have studied positives and negatives. You might have studied exponents and what they do with positives and negatives. And if you can connect what's here, if you can synthesize what's here in this specific presentation with what you generally know about those things, application time, you can get these questions right. But all of that is dependent on you're looking at a problem like this and thinking, why? Why have they given me this? Why have they told me p squared q? Why have they given me that p squared? Why have they given me the things they've given me in the statements, right? Inference is at play all the time when you're doing anything on the test, right? When you're looking at a quant question, you're trying to infer from the specific things you see there to the more general things that you know. And it's all done by asking yourself, why is that there? And coming up with ideally better and better answers. And as such, when you review any question on the test, if you're getting stuck, if you're like, you're trying to do it again, you didn't get it the first time when you did it as part of a time set, so you're coming back to it, you're reviewing untimed. Take all the time you need on review. Review is where you grow. But you're taking your time on it and you're having trouble, try asking yourself, okay, do I know why they've given me this? Do I know why they've given me that? Because almost everything they give you gets used. Here, the fact that PQ is not equal to 0 just rules out a possibility, right? But other than that, almost everything they give you is going to get used in some way in this problem. Almost everything there, in fact, everything there is there for a reason. The author has included it to connect to things that you have studied and that you already know. And seeing that why is what makes all the difference. For anybody wondering how that plays out here, you see less than 0 or greater than 0 in a problem, it's a positives negatives problem. Just generally speaking, that is the truth. And so once you see that it's a positives negatives problem, as many inequality problems are, you can look at the question itself, see p squared q greater than pq squared, and say, hey, I know in positives negatives context that p squared is something positive, right? If it's not allowed to be 0, which is what that given at the beginning is telling us, it's got to be something positive. Same with q squared, right? So really, given that those two are positive, the question can kind of be boiled down to, hey, do we know the signs of P and Q? Do we know whether Q is also positive? Do we know whether P is also positive? And then it's going to maybe be determined by the relative sizes of P and Q. But given that the statements, which we've already peeked at, are just about signs, just about what's positive and negative, we may not have to worry about that. And so knowing that that's why these things are there, the P squared is there because it's a positives negatives question to tell us that that thing is positive, that's different from maybe the next problem in which you see p squared, where that p squared might be there to tell you you're dealing with a quadratic and you'd better factor things out, right? the same signs can mean multiple things. What they're really testing you on when they give you these problems is your ability to look at all the signs and synthesize from those, okay, it's going to be this kind of problem, and so I need to interpret this way, that way. This is the why, that is the why, and so on. You're applying general knowledge in specific settings, but you have to understand why everything's given to you. And once you understand that, you can understand which inferences to make from your general knowledge and bring here. Just to finish it off, statement 1 tells you P and Q have opposite signs, but you don't know which one is which necessarily. Statement 2 tells you P is negative, but that doesn't preclude Q's being, more negative or something like that. But put them both together, P is negative, P and Q have opposite signs, so Q is positive. That means the answer to the question is going to be yes. P squared Q is positive, PQ squared is negative. Yes, that positive thing on the left is going to be greater than that negative thing on the right. Yep, exactly that. All right. It's all inference, you guys, all such skills. Now, there were other problems we might have done, and it would have been great, but I do want to open it up to any other questions you may have before we end this thing. So you have it all together. These are the big types of inference that pervade the test, right? Quant word problems are about seeing how this is connected to this is connected to that. Percent problems, when they tell you 70% of students have red hair, you know that 30% of students do not have red hair, and that kind of inference is necessary to those problems, right? It is everywhere. Do I think substituting works in that one? Kinda, yeah. Like substitution in the algebraic sense is hard with inequalities in general. Just coming back to it, it's hard with inequalities in general, but I also wouldn't be thinking substitution so much as I would be thinking like positives and negatives, right? Because those statements make it kind of inescapable that what they're going for is a positives negatives thing. And so that again informs my interpretation of statement 1. When they say P times Q is negative, and I'm thinking it's a positives and negatives problem, I immediately interpret that as they have different signs, right? That's not the only interpretation you could make of that necessarily, but you can't do much with it algebraically. And it is, of course, in the end, the right interpretation for the context of this problem. Last thing on studying, you guys, basically remember, late stage studying is different from early stage studying. You can't do all your studying by just topics. And hopefully this presentation has convinced you a little bit. It's not even necessarily about the topics. It's about the skill, the problem solving skill that is inference that's being tested all throughout the test. And so especially when you review problems, take the time and make sure that you deeply understand both the problems and you. What did you not see? What connection in the end did you have trouble making in that problem? How should you have seen it? How's the problem signaling it to you? Putting all of that stuff into words, articulating that, making a verbal process of it is how you actually get better at that stuff. And not just in verbal questions, in quant questions, in data insights questions as well. And of course, as you guys will know, a lot of times you get a quant question or a data insights question wrong. It is just kind of a verbal lapse of some kind. You just missed a keyword or misread something or expected them to say something. And even though they said something else, you were kind of playing to your expectations. Anybody who's seen me do the data insights section in some other YouTube video, like, don't watch it if you haven't yet. But you'll see all kinds of verbal lapses there, right? It's not so much data insights that was getting me down on that section. It was words, right? So don't underestimate the power of reading well and of making these kinds of inferences as you're studying anything on the test. And when you go to review the problems, focus heavily on that, especially if you're having trouble getting started on a problem in your late stage studying, when you kind of theoretically know all the information and should be able to do it. And if you got started, would be able to do the rest of the math, figure out, why didn't I see it? What should I have seen? How did the problem signal it to me? And where can I find other problems like this so that I train myself to see this problem in this way, to make these kinds of inferences when I see these kinds of things? Okay. No, that's a really great question. Theoretically, it is nice to interleave, but how? How do you do it? Interleaving, I mean, it depends what kind of interleaving we're talking about, but, switching off between quant, verbal, and data insights, that's pretty doable, right? But in terms of like interleaving topics, depends on what stage of studying you're at. But the official guide online platform is pretty good for like random practice, right? Which random practice in that late stage studying is interleaved practice, right? If you're doing random practice, you are seeing multiple topics, and that's why you want to do plenty of random practice at that stage. Also, of course, as I mentioned before, because it's more test-like. The official guide online platform is really, really good for that. In terms of like targeted follow-up or just interleaved targeted practice in general, the official guide's okay for that, especially as a physical book. But GMAT Club honestly offers one of the best opportunities to do it because, of course, in the forums, you can target specific topics, multiple topics at a time, and things like that. So when you're going for your like follow-up practice on random sets, GMAT Club is a really, really good resource. But in terms of generating random sets and doing interleaved practice like that, the official guides online platform is great. Our at Manhattan Prep's dynamic question set builder is good, and there are various other things out there. And really, look, it's not so much like interleaving is more a process thing than it is a content thing. Like whether you're interleaving or not, you're going to be finding all the same kind of content to study anyway. It's just more about going through the discomfort of mixing it up and studying that way than like trying to make yourself comfortable and studying in a single-minded way, one thing at a time. Like do some quant and some verbal in a day, or some verbal and some data insights in a day, or some quant and some data insights in a day, instead of just doing one thing. And if you are just doing one thing like quant, unless you're skill building and the early studying and trying to get certain topics down, do multiple topics usually, unless you're, of course, following up on stuff you saw before. Great question, Pooja. If you are taking a lot of time when solving a question, does it mean you have a conceptual gap? Depends. Depends on where that time specifically is being taken, right? Are you taking time, for instance, to do the calculations? Then probably not. Then you just need to practice calculations more, right? But are you taking time to do calculations that didn't even need to be done had you seen a way around it? Then that might be an inference or a planning gap, right? And what you really want to get to, especially with quant, is a place in which you can look at a problem and kind of plan it out. And all of that comes from inferences, first and foremost, seeing what's there, why it's there, and understanding what kind of problem it is, but also connecting to your past experiences and thinking, okay, I could do it that way, but I can kind of like, I've seen this before, I've done things like this before. I know that if I do it this way, it's going to take me 3 minutes, right? Or I could do it that way. I can kind of see that if I use this, it'll connect with that. And yeah, that'll work out. Like when you're planning a problem, when I'm planning a problem at least, and I'm thinking, should I do this algebraically or should I do it numerically? I'm thinking especially about the like numerical approach as, okay, if I have this number, what's it connecting to up there? What does it give me? What am I going to do with that thing that it gives me to carry the problem forward? And so that's very much how I will plan out how to do a problem, right? And how then I can get through a lot of problems pretty quickly because I'm choosing pretty judiciously in the beginning, which path am I going to go down? But still, all of that is mediated by inference. All of that is like, if I do this, it connects to this. If I connect these two, I'll get this sort of thing, and that'll connect to this next thing, and so on. So you can plot out a path through a problem almost without doing it when you get good at planning. And so that would be one of the goals. If you find you're slow on problems, just in general, planning well in the beginning to choose the right course of action on the problem can save you time because there's usually a longer way and a shorter way. But also planning can save you time in actually doing it because you're just kind of filling in the blanks when you go to do it. It's almost like brainstorming an essay before actually writing it. It feels more like filling in the blanks. That's how you want a problem to feel. And the better you get at inferences, the more problems come to feel. With that, I will end it. Thank you, Abhijit and GMAT Club, for hosting these sessions. I hope they were very helpful to you. If you guys have any questions you want to ask, my email address is right there. Feel free to reach out. Oh, it should have been right there, but it's not. There it is. Feel free to reach out, you guys, and have a great rest of your day or night.